Hello everyone, myself Revati, Assistant Professor, Department of Artificial Intelligence and Data Science, Ramco Institute of Technology. In this lecture, we are going to discuss about directed acyclic graph. Before that, we must know what is graph. A graph can be defined as a group of vertices and edges that are used to connect these vertices. A graph can be seen as a cyclic tree where the vertices maintain any complex relationship among them instead of having parent child relationship. Graph is nothing but a data structure or a non-linear data structure. It made up of a finite number of nodes or vertices and the edges that connect them. So this is the example of a graph, a directed graph. So in this graph, we defined a graph G of V comma E with five vertices, that is A, B, C, D and E. Then it consists of six edges, that is A comma B, B comma C, C comma E comma D, D comma P and D comma A is in the following figure. In this, the graph terminologies can be described. The graph terminologies are as follows: a path, closed path, simple path, cycle, connected graph, complete graph, weighted graph, digraph, loop, adjacent nodes, degree of the node. We will see one by one. So, a path can be defined as a sequence of nodes that are followed in order to reach some terminal node V from the initial node U. Whereas closed path is defined as a path will be called as closed path if the initial node is same as terminal node. A path will be closed path if V not equal to Vn. And a simple path is if all the nodes of the graph are distinct with an exception V not equal to Vn. Then such path P is called as closed simple path. The next one is cycle. A cycle can be defined as the path which has no repeated edges or vertices except the first and last vertices. Then a connected graph. A connected graph is the one in which some path exists between every two vertices u, v in capital V. There are no isolated nodes in a connected graph. The third one is a complete graph. It is one in which every node is connected with all other nodes. A complete graph contains n of n minus 1 by 2 edges where n is the number of nodes in the graph. Then the weighted graph in each edge is assigned with some data such as length or weight. The weight of an edge E can be given as W of E, which must be a positive value indicating the cost of traversing the edge. And a digraph is a directed graph in which each edge of the graph is associated with some direction, and the traversing can be done only in the specified direction. Next one is loop. A loop is an edge that is associated with the similar endpoints can be called as loop. The adjacent nodes of the graph is defined as if two nodes U and V are connected through an edge E, then the nodes U and V are called as neighbors or adjacent nodes. The final one is degree of the node. It is the number of edges that are connected with that node. A node with degree 0 is called as isolated node. In this part, we learn what are the different types of graph involved in data structure. So in this we are discussing cyclic graph and another one is a acyclic graph. In a cyclic graph, it should consist of at least one cycle. If a graph has a minimum of one cycle present, it is called as a cyclic graph. And a acyclic graph, if zero cycles are present, and an acyclic graph is an complete opposite of a cyclic graph. So here a DAG, that is abbreviated from the directed acyclic graph, is a fundamental concept in graph theory. So, directed acyclic graphs are used to show how things are related or depend on each other in a clear or organized way. In this, we are going to learn about what is directed acyclic graph and what are all the properties, then the application in real life. The term directed acyclic graph is strictly speaking a DAG is a mathematical concept and nothing particularly innovative in and of itself. Here, the direct acyclic graph has two important features. So, one is the directed edge and another one is the acyclic. In a directed edge, each edge has a direction, meaning it does goes from one vertex to another. This direction signifies a one way relationship or dependency between nodes. Then the another feature is acyclic. The term acyclic indicates that there are no cycles or closed loops within the graph. In other words, you cannot traverse a sequence of directed edges and return to the same node. Then, so these are all the some of the properties of directed acyclic graph. One is the transitive closure and another one is the topological sorting. In a transitive closure, for example, we are taking Washer and Floyd's algorithm. Given the directed graph, determine if a vertex j is reachable from another vertex I for all vertex pairs I comma j in the given graph. Here, reachable means that there is a path from vertex I to j. The reachability matrix is called as the transitive closure of a graph. The another one is a topological ordering. Is a topological chart or topological ordering of a directed graph is a linear ordering of its vertices such that for every directed edge u comma v from vertex u to vertex v, u comes before v in the ordering. So, some of the applications of directed acyclic graphs are routing in computer networks. So, routing is a process of selecting and defining paths for IP packet traffic within or between networks, as well as the process of managing network traffic overall. The second one is job scheduling. In job scheduling, this is a process where different tasks get executed at predetermined time or when the right event happens. Then the third one is citation graphs. In a citation graph, the vertices are documents with a single publication date. The edges represent the citations from the bibliography of one document to other, necessarily earlier documents. Thank you.